In this video, we're going to talk about another combination of function transformation problem from Newton. So here we're given the graph y equals f of x. It's the curved, or the dashed function here. And they ask us to drag these 2 points around so that it forms the graph of y equals 3 f of x plus 4 minus 3. And so that is a combination of transformations. And so what we need to do is to kind of pick that apart and figure out which of the basic transformations can I combine to make that transformation. And remember, the order matters in which you do these things. And that's a fairly tricky little part right here. This table here shows all the transformations that we have. We can add k or subtract k from f of x, replace x by x plus k or x minus k, multiply f of x by some number k, and replace x by kx, and multiply by minus 1 or replace x by minus x. So symbol wise, right, that's what these will look like. And so what we're going to do is to figure out how can we combine these transformations to get that graph that they asked us to graph. And then once we do that, then we'll just apply these point-wise effects to drag those points around into the right place where we need them. Okay? All right, so what we would want to do is start with f of x here. Okay? And there's a couple of things that you could do first. This x plus 4 and this 3 are fine to do first. You got to be careful about doing the subtraction part first. I'm kind of leave that one to last because that in conjunction with this multiplying by 3 can really change the issue here. Okay, so I'm going to start with y equals f of x, and the first thing I'm going to do is replace x by x plus 4. Okay. And so when I do that, symbol wise, I'll get this f of x plus 4, right? And so here I'm looking at this transformation. And so what I will do is subtract k from each x value in there. So I make a note of that. I will subtract 4 from each x value. All right, and then here is kind of a critical place. If I do that first, then I must multiply this by this 3. If I do the subtracting 3 and then multiply by 3, that would really be 3 times minus 3 and make that a 9, which is not what I want. So the next thing I'm going to do is I'm going to multiply the function by 3. So multiply f of x by 3. That's one of the basic transformations right here. Okay. And you can see the point-wise effect that one will have is that each point I'm going to have to multiply the y value by k, in this case 3. Right? So that's what I have here. I'm going to multiply each y value by 3. And now the only thing left, right, is this minus 3, which again I kind of recommend you'd leave to the end usually. All right, and then I'm going to subtract 3, right? So I'll put this minus 3 on the end, and the effect that will have is that it's this one right here. I'll take the function and subtract 3, so I will then subtract 3 from each y value. And so that's it. That combination of transformations will get the graph that they want us to graph out. Okay. So now I go to the graph. And again, I normally like to line these things up. You'll notice when I try to line this one up, in some spots it's not going to work out. That's because the dotted graph doesn't really go through one of the grid points right here. So I'm going to, when I drag mine here to make those line up, which I like to do in these problems, I'm going to drag it to a point where it lines up perfectly like this. And then I'm going to work with these 2 points and apply those transformations. Okay, so going back to our list of transformations, the first one is we are going to subtract 4 from each x value. So have this point, and you can click on it and see that the x value is 0. So 0 minus 4 would be negative 4. So this will move to negative 4, 0. The other point, which is right here at 1, 1, right? 1 minus 4 will give me a negative 3, 1. So, and that's kind of nice. Some of these transformations you have to do them separately, but when you do a horizontal shift or vertical shift, it drags the points along, which is kind of nice. Okay, so on to the next one. On the next one, it says the pointwise effect was to multiply each y value by 3. Okay, so when I click this green point, its y value is 0. 0 times 3 is 0, so that point actually stays put. Doesn't move anywhere. On this one, right, the y value is 1, and 1 times 3 is 3. So that point will get moved up to minus 3, 3, like this. So you see that the graph, oops, sorry, went too high. So you can see that the graph, the dashed graph, gets stretched basically like that. Okay, and next one is okay, the next pointwise effect is then subtract 3 from each y value. Okay, so I would go here, the y value here is 0, so 0 minus 3 would be negative 3. So, and you can see that this one also gets dragged down too, which is really nice as well. Okay, and that's it. We've applied all those pointwise effects, so go to submit, and we can see that it worked out.